You've walked past it 100 times, kicked it with your boot, maybe even sat on it during lunch. A rock. Just another rock. But what if I told you that rock was screaming at you? What if every crack, every color, every strange pattern was a message written in geological code? A code that says, gold, right here, under your feet. Because here's the truth most people never learn. Gold doesn't announce itself. It doesn't sparkle on the surface like in the movies. It hides. And when it hides, it leaves clues, patterns, signatures written in stone over millions of years. The earth keeps receipts, and today, we're learning to read them. This isn't about luck. This isn't about wandering the wilderness hoping to stumble on a nugget. This is about pattern recognition, about understanding that gold follows rules, geological rules. And once you know those rules, once you can read the language of stone, you'll never look at a hillside the same way again. In the next 30 minutes, I'm going to show you the exact rock patterns that have led to some of the biggest gold discoveries in history. Patterns that are still out there, still visible, still waiting for someone with trained eyes to find them. So let's stop walking past fortune. Let's start recognizing it. The Golden Highway, understanding veins. Deep underground, millions of years ago, the earth was cooking. Water, superheated to hundreds of degrees, became pressurized like a geological pressure cooker. And in that water, dissolved metals, silica, sulfur, everything the Earth's crust could offer. That water needed an escape route. Enter fractures, cracks in the bedrock, faults, weaknesses in the stone. And when that superheated mineral-rich fluid forced its way through those cracks, something magical happened. As it rose, as it cooled, minerals began to crystallize, layer after layer, year after year. What you end up with is a vein, a geological highway frozen in time. Now, not every vein contains gold, but every gold-bearing vein follows certain patterns. And that's what separates the prospector from the hiker. First, composition. Gold loves quartz. From California's Mother Lode, to Australia's Golden Triangle, to South Africa's Witwatersrand, quartz veins are the common thread. Why? Because quartz and gold crystallize under similar conditions. They're geological companions. But here's the key. It's not just any quartz vein. It's the cross-cutting veins. The ones that slice through the host rock at odd angles. The ones that look like they're fighting against the grain. These are hydrothermal veins, formed by those superheated fluids. They're younger than the rock they cut through, and they carried the gold up from deep below. Second, look at the vein structure. Gold prefers complexity. Where veins intersect, where they split and merge, where multiple fractures meet, you get what geologists call a stockwork zone. Think of it like a highway interchange. All that traffic means more opportunity for gold to accumulate. Third, check the borders. Look at where the vein meets the host rock. Is there discoloration, alteration, a halo of different colored stone? That's chemical weathering from those hot fluids. It means the vein was active, aggressive, mineral-rich. A prospector in Nevada spent 3 summers mapping quartz veins on a hillside. He noticed that every vein running northeast-southwest showed iron staining near the edges. Where 3 of those veins intersected, he found a greenish alteration. He staked his claim right there, dug down 20 feet, and hit a vein carrying half an ounce of gold per ton. All because he read the pattern. So when you're out there, don't just see veins. Read them. What direction do they run? Do they intersect? What's happening at the contact zone? Is there oxidation, staining, alteration? Because gold doesn't randomly appear. It follows the highway. The rust that reveals, iron staining, and oxidation. Now, let's talk about something most people ignore, rust. That reddish, orangish, yellowish staining you see on rocks. Most hikers think it's just weathering. But to a prospector, rust is a spotlight. A geological announcement that something important happened here. Here's the science. When iron-bearing minerals like pyrite are exposed to oxygen and water, they oxidize. They rust. And here's the golden connection. Pyrite is called fool's gold, not because it looks like gold, but because where you find one, you often find the other. A gold-bearing quartz vein forms deep underground, containing not just gold, but pyrite, arsenopyrite, chalcopyrite. Over millions of years, erosion exposes that vein to the surface. The sulfides oxidize. They turn red and orange. They break down. And in that process, gold, which is chemically stable, gets freed and concentrated. What you're seeing when you spot iron staining is the gossan. A gossan is an oxidized cap sitting on top of a sulfide-rich vein. In the old days, miners would search specifically for gossans. They called them iron hats, because finding an iron hat meant finding a vein. But not all iron staining is equal. Here's what to look for. Color intensity. Bright orange and red staining, especially in bands or halos around veins, is a strong indicator. You want concentrated, vivid discoloration. Association with other minerals. Is the iron staining accompanied by white quartz? By green copper stains? By dark, heavy rocks? If yes, you're looking at a polymetallic system, exactly where gold likes to live. Boxwork structures. Sometimes when pyrite weathers away, it leaves behind a honeycomb pattern in the rock, like a 3D lattice. If you see boxwork in quartz or surrounding rock, stop and investigate. You might be standing on a weathered ore body. In Western Australia, a geologist was mapping iron formations. He noticed certain outcrops had localized zones of intense red and orange staining with a chaotic, fractured pattern. He took samples. They came back with gold values. He traced the staining pattern along the ridge, found where it intersected with a quartz vein. Within 2 years, that observation turned into a multi-million-ounce gold deposit, all because he didn't ignore the rust. After rain, iron staining becomes more vivid. The moisture brings out the colors. That's the best time to scout. Early morning after a storm, when the rock is still damp and the colors are screaming. Fractures, faults, and shear zones. To really understand where gold comes from, we need to talk about the underground highways, the fractures, the faults, the shear zones. These are the pathways gold traveled to get where it is today. A fault is where rock has moved along a fracture plane. One side shifted up, down, or sideways. That movement creates open space where fluids can flow and minerals can deposit. It also generates heat from friction, which keeps those fluids hot and reactive. Not all faults are gold-bearing, but certain types are gold magnets. Strike-slip faults where movement is horizontal often create pull-apart zones, areas where the fault bends or steps, creating open space. California's gold districts sit along subsidiary faults connected to the San Andreas system. Shear zones are like faults on steroids. Instead of a single fracture, you have a whole zone of crushed, pulverized, recrystallized rock. And gold loves shear zones. They're permeable like geological sponges. Some of the world's largest gold deposits are in shear zones. The Abitibi Belt in Canada, the Yilgarn Craton in Australia, the Birimian terrains of West Africa. How do you recognize these features in the field? Linear, topographic features. Faults and shear zones create straight lines in the landscape. Ridges that run arrow straight. Valleys that cut perfectly linear. Creek beds that suddenly change direction at sharp angles. Follow them. Crushed rock zones. Where there's shearing, rock gets pulverized. Look for areas where normally hard rock is crumbly, fractured, or altered. It looks messy, broken, unstable. But it's a sign of intense structural activity. Quartz veining in linear arrays. Multiple quartz veins all running parallel, all spaced evenly, means you're probably looking at a fault or shear zone. Slickensides. These are polished, striated surfaces where fault movement occurred. They look like someone rubbed the rock with sandpaper, creating grooves. If you find slickensides, you've found direct evidence of faulting. A prospector in the Yukon kept noticing a band of intensely fractured rock running along a hillside, maybe 50 feet wide, traceable for miles. The rock was darker, more chloritic, classic shear zone indicators. He climbed up to investigate, found quartz veins, found iron staining. Samples ran over 2 grams per ton gold. He traced that shear zone for 3 miles. That discovery eventually became a producing mine. Folded rocks and pressure traps. Rock doesn't always crack under pressure. Sometimes it bends. And when it bends, it creates some of the most productive gold traps in geology. Picture layers of rock lying flat like pages of a book. Then, tectonic forces squeeze them. The rock warps. It folds. You get anticlines where layers arch upward, and synclines where they sag downward. Why does this matter for gold? Because folding creates structural traps. When rock folds, the outer arc stretches and cracks form. The inner arc compresses and fluids get squeezed into the hinge zones, the tightest part of the fold. That's where minerals accumulate. Gold-bearing fluids follow the same pattern. They exploit the fractures and stretched layers. They pool in hinge zones, and they deposit where pressure and chemistry align. The Bendigo Goldfield in Australia, the Carlin Trend in Nevada, the Ashanti Belt in Ghana all feature intensely folded rocks with gold mineralization aligned to fold structures. How do you spot folded rocks? Visible layering. If you see distinct layers that are curved, wavy, or contorted, you're looking at folds. Trace those layers with your eyes. That curvature is your clue. Repeated rock sequences. In folded terrain, you sometimes see the same rock type appear multiple times as you walk. Folding has brought the same layer back to the surface repeatedly. Change in dip direction. If rock layers tilt one way on one side of a ridge and the opposite way on the other side, you've walked over a fold axis. That axis is a prime target. Intense fracturing near hinges. Fold hinges are stress points. Look for areas where layered rock is heavily broken up. Those are hinge zones. In Ethiopia, a geological team mapped intensely folded schists and metavolcanics. They identified a large syncline running for several kilometers. Using structural analysis, they predicted gold should concentrate along the eastern limb, where fold-related fractures intersected quartz veins. They drilled, and they hit high-grade gold. The fold geometry had focused the mineralization exactly where predicted. That became the Tulu-Kapi gold deposit. Folds are subtle, but if you train your eye to see layering, to trace curves, to think in 3 dimensions, you unlock a whole new dimension of prospecting. Alteration, halos, the invisible fingerprint. Now I want to show you something more subtle. Something most prospectors overlook because it doesn't look valuable. It looks dull, weathered, unimpressive. But it's one of the most reliable indicators of nearby gold. I'm talking about alteration halos. When hydrothermal fluids move through rock, they don't just deposit minerals. They also alter the rock they pass through. They change its chemistry, its mineralogy, its texture. And those changes create a halo around the mineralized zone, a fingerprint left behind by the fluids. And here's the powerful part. Alteration halos are often much larger than the vein or deposit itself. You might not see gold. You might not even see a vein. But if you see the alteration, you know you're close. Several types of alteration to watch for. Silicification. The rock becomes saturated with silica, turning hard, glassy, and resistant to weathering. Silicified zones often stand out as ridges. The rock might look bleached or pale. If you strike it with a hammer, it rings like glass. Sericitization. Feldspar minerals break down into sericite, a fine-grained mica. The rock becomes soft, crumbly, and shiny with a greenish or silvery sheen. Argillization. Rock turns into clay. The feldspars break down completely, and the rock becomes weak, easily eroded, often white or pale gray. Chloritization. Minerals turn green due to chlorite formation. The rock takes on a dark green, sometimes blackish green color. Multiple alteration types often overlap. You might see a core zone of silicification surrounded by a halo of sericitization, which grades outward into argillization. This zoning is classic for gold systems. The core zone is where the vein or deposit is likely located. Imagine a target, a bullseye. The center is the gold-bearing vein. The first ring around it is silicified rock. The second ring is sericitic. The third ring is argillic. As you walk across the landscape, you're walking from the outer rings toward the center. If you recognize the outer rings, you can navigate to the bullseye. In northern Chile, a prospector kept noticing areas where rock was bleached, almost white, standing out against darker volcanic background. After seeing it multiple times, always in linear zones, he investigated. He sampled the bleached rock. It was intensely silicified. Don't just look for quartz and rust. Look for changes in the rock itself. Color changes, hardness changes, texture changes. Ask yourself, why does this rock look different? Epithermal systems, where surface meets treasure. Let's talk about a specific type of gold system that forms close to the surface. Epithermal deposits. These are exciting targets because they're accessible. You don't need deep mining. Sometimes you can literally chip gold off the outcrop. Epithermal systems form in volcanic areas where hot water circulates near the surface. Think hot springs, geysers, volcanic vents. The water is heated by magma below, rises quickly, boils near the surface, and deposits minerals. The result: high-grade gold in shallow, easily accessible veins. There are two main types. Low sulfidation systems form from neutral pH fluids. They produce quartz veins with beautiful textures, banding, coliform layers, vugs, cavities, and sometimes visible gold and silver. Famous examples include the Comstock lode in Nevada and Hishikari in Japan. Look for banded quartz veins with multiple colors and textures. Vuggy quartz, full of cavities where crystals once grew. Sinter terraces, silica deposits that form at hot springs. High sulfidation systems form from acidic fluids. They're more aggressive. The alteration is extreme. Rocks are bleached, silicified, turned into a moonscape of pale, barren-looking terrain. But beneath that surface, there can be spectacular gold grades. Examples include Yanacocha in Peru and Pueblo Viejo in the Dominican Republic. Look for intense silicification and advanced argillic alteration. Residual quartz, where everything else has weathered away. Steep-walled veins with massive quartz. Epithermal systems leave surface expressions. You can sample the mineralization with a rock hammer. Picture this. You're hiking through volcanic terrain. You start seeing quartz float, loose pieces eroding out of the hillside. You follow them upslope. The float gets more abundant. Then, you see an outcrop. The quartz is banded, alternating white and gray layers. You break a piece. It's full of tiny cavities. Some have iron staining. The rock around the vein is pale, altered. That's a textbook epithermal vein. A prospector in Mexico found banded quartz veins on a hillside in the Sierra Madre. The veins were narrow, but had beautiful textures, and the local rock was intensely silicified. He took samples. The assays came back with both gold and high silver values. He traced the veins along the hillside, found more. Eventually mapped out a vein swarm over a kilometer long. That discovery attracted a major mining company and became an operating mine. Epithermal systems are everywhere. There's been volcanic activity. Western United States, Mexico, Central and South America, Indonesia, the Philippines, New Zealand. And epithermal systems often occur in clusters. If you find one vein, there are likely others nearby. Placer patterns, reading ancient rivers. Let's not forget the gold that's already been freed. Placer gold. Gold that's been eroded out of its host rock and deposited in streams, rivers, and ancient gravels. Placer prospecting is accessible. You can pan a creek and see gold that same day. But successful placer prospecting isn't random. It's about recognizing patterns. Gold is heavy. When it's freed from rock and enters a stream, it sinks fast. It doesn't travel far before dropping. And when it drops, it seeks the lowest points where water slows down. Key patterns. Inside bends of streams. Water moves fastest on the outside of a bend and slowest on the inside. That's where heavy particles drop. Behind large boulders. Boulders create eddies, zones of slow water where gold settles. Always check downstream of big rocks. Bedrock crevices. Gold works its way down through gravel until it hits bedrock. Then, it settles into cracks and pockets. False bedrock. Sometimes a hard clay layer acts like bedrock, stopping gold from sinking further. Gold can accumulate right above it. Confluence zones. Where two streams meet, turbulence increases and gold drops. Changes in gradient. When a steep creek flattens out, water speed drops and gold settles. But here's where it gets interesting. Ancient river channels. Not every placer is in a current stream. Many of the richest placers are in rivers that no longer exist. Rivers that flowed thousands or millions of years ago. These ancient channels, called paleochannels, can be buried under newer sediments or left high and dry on hillsides. Linear topographic features. Ancient rivers leave subtle valleys and benches. Does that hillside look like it was once a valley? The California gold rush wasn't just about panning active streams. Many of the biggest fortunes came from buried channels in the Sierra Nevada foothills. These deep leads were ancient rivers buried under volcanic flows. Miners followed them for miles underground. A prospector in Montana was working a creek with modest gold. But he noticed a bench on the valley wall, about 50 feet above the current stream. He hiked up, found gravel, rounded cobbles, classic river deposit. He panned some soil. Gold. Better gold than down in the creek. He spent the summer tracing that bench. It ran for half a mile. He estimated that ancient river had deposited thousands of yards of gold-bearing gravel. Don't just prospect the active streams. Prospect the landscape. Read the history written in terraces and benches. Because rivers move, but their gold stays behind. Putting it all together. We've covered veins, faults, folds, alteration, epithermal systems, placers. Different patterns, different clues. But gold prospecting isn't about memorizing a list. It's about developing vision. It's about walking into the wilderness and seeing what others don't. The earth is a storyteller. Every rock, every color, every crack is a sentence in a story that spans millions of years. Your job as a prospector is to read that story. When you see a quartz vein, ask, where did this come from? What event created it? Is it related to a fault? Does it intersect other structures? Is there alteration around it? When you see iron staining, ask, what oxidized here? Is this the top of a sulfide vein? What's below the surface? When you notice folded layers, ask, where's the hinge? Where's the stress concentration? If fluids move through here, where would they pool? This is pattern recognition at its finest. It's not luck. It's geology, plus observation, plus persistence. Let me share one final story. In Western Australia, a prospector named Jim had been prospecting for 20 years with modest success. Then, he decided to get serious about geology. He took courses, read textbooks, and he started prospecting differently. He chose a district that had produced gold in the 1890s, but had been largely abandoned. He obtained geological maps and aerial photos. He walked every ridge, every valley, marking quartz veins on his GPS. After 3 months, he had mapped over 200 veins. Then, he analyzed them. He noticed most veins ran northeast, but a small cluster ran northwest. And where those two trends intersected, there was intense iron staining, folded greenstone, and multiple alteration zones. Nobody had ever staked that specific spot because it was between the old workings. Jim staked the ground, hired a drilling contractor, and the first hole hit 20 meters of ore-grade gold mineralization. The intersection of those two vein trends had created a structural trap that focused the gold. That discovery changed Jim's life, but the clues were always visible. The veins outcropped at surface. The staining was obvious. The structure was mappable with basic tools. Jim didn't find that gold because he was lucky. He found it because he learned to read patterns. Conclusion: the next time you're hiking in gold country, slow down. Look at the rocks beneath your feet. Study the colors, the textures, the angles. Ask yourself, what story is this rock telling? What forces shaped it? What fluids moved through it? And could those fluids have left gold behind? Because somewhere out there, in mountains you can see from the highway, in valleys you've driven past 100 times, in creeks you've fished without thinking, there are patterns, rock patterns, geological signatures, silent messages written over millions of years. And those patterns are saying, gold, right here, if you know how to look. The difference between finding gold and walking past it isn't luck. It's knowledge. It's vision. It's the ability to read what the earth is telling you. And now, you have that ability. You know what to look for. You understand the patterns. So get out there. Walk the trails with new eyes. Study the stone. Read the patterns. Because the gold is waiting. It's been waiting for millions of years. And it's waiting for someone who knows how to see it. Someone like you. If this video opened your eyes to the hidden language of gold-bearing rocks, hit that like button. Subscribe to the channel because we're going deep into prospecting techniques, real discoveries, and field guides. Drop a comment and tell me, what's the most interesting rock pattern you've ever seen? Have you found gold by recognizing geological clues? Finally, remember this fundamental truth. No single pattern, no matter how promising, can guarantee the presence of gold. The earth is far too complex, far too ancient, and far too mysterious to reveal its secrets through just one clue. But here's where the real magic happens. When multiple indicators begin to converge in the same location. When you discover iron-stained quartz veins cutting through folded rock structures. When you notice alteration halos spreading across favorable host rock types. When geological formations align like pieces of an intricate puzzle. You're no longer operating on hope or chance. You're no longer relying on blind luck or wishful thinking. You're reading the Earth's blueprint, deciphering a language written over millions of years, understanding the very code that nature used to deposit her most precious metals. At Gemstone Empire, we're not just chasing rocks across mountainsides and creek beds. We're doing something far more profound. We're uncovering the hidden language of the Earth itself, one pattern at a time, one geological mystery at a time, one golden discovery at a time. This is our passion, our purpose, our calling. Don't forget to subscribe for more real gold stories pulled from actual field experiences, field-tested techniques that work in the real world, and insider geology straight from the front lines of nature's greatest treasure map. Until next time, keep your eyes sharp and observant, your pans ready for action, and your belief unshaken in the possibilities that lie waiting. Because the land never lies. It only waits for someone who knows how to listen. This is Gemstone Empire, where the earth speaks its ancient secrets, and you learn to listen. Fortune doesn't favor the lucky. It favors the observant. Now get out there and read the rocks. Your discovery is waiting.